All right, strap in, everyone. We're going deep today. Imagine computers understanding language like we do, not just spitting out pre-programmed phrases.
Yeah, like really getting it.
Exactly. That's what this paper, Improving Language Understanding by Generative Pre-training, is all about.
And get this, it's not just theory. They actually made it work.
This team, Alec Radford, Karthik Narasimhan, Tim Salomons, and Ilya Sutskever, they're onto something big.
Huge. They use this method, generative pre-training, with a model called a transformer. Might sound like sci-fi, but bear with me.
We're talking about training on a massive data set of unpublished books, which is kind of brilliant when you think about it.
It is, right?
Yeah.
Like giving the computer a crash course in, well, reading before testing its language skills.
See, getting computers to truly understand language, that's been the holy grail for ages.
Oh, absolutely. And those old methods needed tons of data, all labeled by hand. Talk about slow and expensive.
This team, they flipped the script. They decided to use all that unlabeled text out there, the stuff just waiting to be learned from.
Mountains of it. So instead of spoon-feeding the computer-labeled examples, they basically let it loose in a library.
Let it roam free, huh?
Exactly. It's this generative pre-training where the model learns to predict the next word in a sentence, kind of like reading a mystery novel and trying to guess the ending.
But on a massive scale.
Yeah.
So by going through all these books, the model starts to absorb the nuances of language, right?
Right.
The grammar, the subtle ways we use words to mean different things.
You got it. And that's where the transformer model they used comes in. It's designed to see connections between words that are far apart, just like we do when we're really digging into a complex article.
Hold on, back up a sec. What's so special about this transformer thing? I'm getting lost in the jargon here.
Sure. Think of it like those older models, they were like short-term memory champs. Great for understanding a sentence, but not the whole story.
Okay, so they're like remembering a phone number. Impressive, but not exactly deep understanding.
Exactly. Transformers, on the other hand, they're the big picture thinkers. They can connect ideas across paragraphs, see how everything fits together.
So more like understanding the plot of a movie, seeing how all the scenes connect.
Perfect analogy. And that ability to see the big picture, that's key for truly getting language, how ideas build on each other.
All right, so they've got this model trained on a mountain of books. It's got this transformer superpower. What did they actually do with it? What did they test it on?
They didn't hold back, threw 12 different language tasks at it, and we're not talking easy stuff. Natural language inference, that's like figuring out if one sentence implies another.
Whoa, that's getting pretty high level.
Oh yeah, and question answering based on a text, even seeing if two sentences mean the same thing, like paraphrasing.
So it's like testing the model's reading comprehension, but across all these different subjects.
Precisely. And here's the kicker. They got state-of-the-art results on 9 out of the 12 tasks. They even beat systems specifically designed for each task.
No way.
Mm-hmm.
So this whole generative pre-training thing, it wasn't just a one-trick pony. It could actually adapt and perform across the board.
You got it. And what blew my mind, how well it did on some tasks without any specific training. Like they gave it the word very and asked, is the next word going to be positive or negative?
And it could figure that out just from reading tons of books.
It did. It's like the model developed this intuition about language just by being exposed to so much of it.
That's wild. So we've got computers reading like humans, understanding complex relationships between words. Feels like we're on the edge of something massive here.
Oh, we are just getting started. Yeah, it really changes the game, doesn't it? Imagine AI summarizing these complex papers, pulling out the key points, making it all easy to digest.
Oh, the time we'd save. No more slogging through pages of jargon. We'd have an AI assistant giving us the gist in minutes. Kind of like what we're doing now, just, automated.
Exactly. And customer service, forget those clunky chatbots that barely understand your question. We could have AI that actually gets what you need, gives you real solutions.
Speaking of chatbots, I had a rough one myself recently. But let's stick to this paper for now. There's this thing, task-specific input transformations, that caught my eye. Sounds a bit technical. What's that all about?
It is a bit, but it's a cool idea. You see, the model's trained on this massive amount of text, right? Just a continuous flow of words.
Like reading in a never-ending book.
Exactly. But most language tasks, they're more structured, like comparing two sentences or answering questions from a document.
So how do you get this model that's used to reading like a novel to handle those structured tasks? Sounds like a mismatch.
That's where these input transformations come in. Think of it like giving the model different sets of glasses to wear, depending on what it's doing.
Glasses. Okay, I'm intrigued.
So for question answering, it puts on its detective glasses to scan the text and find the answer. For sentiment analysis, it's emotion detecting glasses to pick up on the vibes.
So instead of rewiring the model for each task, you're just giving it a different lens to look through.
Exactly. For example, with textual entailment, figuring out if one sentence implies another, they just combine the two sentences with a special symbol in between. Boom, one sequence for the model to understand.
Clever. So you adapt the input to fit the model, like translating a document into a language it already speaks.
Perfect analogy. And for question answering, they get even fancier. Take the document, the question, each possible answer, string them together with special symbols. Each answer gets its own sequence.
So the model's reading each answer in context, then figuring out which one fits best, kind of like giving it a multiple choice test with extra clues.
Exactly. And the cool part, they did all this without messing with the model's core structure. Super adaptable, super efficient.
It's like a Swiss Army knife of a model, one tool for a whole bunch of jobs. But does it have limits? Can it handle things like humor or sarcasm where you need to read between the lines?
Ugh, you've hit on a big challenge in AI right now. This model's amazing, but some aspects of language are still tricky. Humor, sarcasm, they depend on social stuff, emotional intelligence, even the speaker's intention. AI's still catching up there.
So we've made huge strides, but AI fully replicating human communication, that's still a ways off. Like teaching a computer to get a good pun, it might understand the words, but the humor, that's another level.
You nailed it. But this research, it's a massive step forward. The focus on generative pre-training, it's opening up so many possibilities.
It really makes you wonder what's next. If computers can read and understand like this, what else can they do? Could they help us write more creatively, analyze data in new ways, maybe even translate languages with more nuance?
The potential is huge. This research, it's just the tip of the iceberg. As we refine these models, give them even more data, who knows what we'll discover?
Exciting stuff. But before we get too carried away, let's back up a bit. How did they actually train this model? What data did they use? What were the steps involved? Let's get into the nitty-gritty. Okay, let's lift the hood and see what's going on in there. What did they feed this model to make it such a language whiz?
Well, they use this data set called book corpus. It's a collection of over 7,000 unpublished books.
Unpublished books. Huh. Why that choice? You'd think something like Wikipedia or a ton of news articles would make more sense, to train an AI.
Yeah, you'd think so, wouldn't you? But here's the thing. They specifically wanted long stretches of text, like a continuous flow.
Okay, I see. Wikipedia is more like a bunch of separate entries. Factual, sure, but not exactly a flowing narrative. But with books, the model can see how ideas connect over chapters, how the language evolves.
Exactly. Book corpus, it gave them that immersion in language like you get from reading a novel. They wanted the model to really understand how language unfolds, over those longer sequences.
Makes sense. So how'd they actually train the model on all these books? Did they just tell it to read and hope for the best?
Haha, not quite. They used this technique called language modeling. Imagine giving the model a sentence, but you leave the last word blank.
Okay, I'm picturing it.
And the model's job is to predict what that missing word should be, based on all the words that came before it.
So it's like a giant AI-powered game of fill in the blank. And by doing that over and over and over again with thousands of books, it starts to learn the patterns of language.
You got it. It's basically teaching itself the grammar rules, the little nuances of word choice, all by trying to predict that next word.
So that's where the transformer model comes in, right?
Right.
Its ability to see the big picture, to connect words that are far apart. That's got to be key here.
Oh, absolutely. The researchers actually compared it to a more traditional model, an LSTM, and they saw a big drop in performance with the LSTM. It just couldn't keep up.
The LSTM just couldn't handle it, huh?
Nope. The transformer was the right tool for the job. It could handle those long stretches of text, the complicated relationships between words, in a way that the other models just couldn't.
Like the difference between trying to solve a jigsaw puzzle with all the pieces scattered everywhere versus having a few sections already done, right? The transformer could see the connections, the groupings of ideas, and make sense of them.
Yeah, a perfect way to put it.
This is amazing. We've got computers reading like humans, understanding complex language. It feels like a real turning point in AI, What do you think this means for the future? Where are we going with this?
It's hard to say for sure, but I think this research, it's opened up a whole new world of possibilities.
Yeah.
Just imagine AI that can analyze tons of text, not just for information, but for actual understanding.
Well, yeah.
Think legal documents, scientific papers, even historical archives. We could use AI to unlock all sorts of insights and knowledge that were buried in all that text.
It's like having an army of super smart research assistants who can go through mountains of information and find all the good stuff. And not just research. Think about education, healthcare, even creative fields like writing or composing music. The possibilities are, well, endless.
They really are. It's an exciting time to be working in this field. And this is just the start. As we build even better models and feed them even more data, who knows what amazing discoveries are waiting for us.
That's inspiring. Well, folks, that wraps up our deep dive into the world of language understanding and generative pre-training. We covered a lot, from training on unpublished books to the power of the transformer model. If this piqued your interest, I encourage you to check out the original research paper and see where your own deep dive takes you.
And never stop being curious, keep exploring, and keep on learning.